This is Brad Ritchie from QA Cafe Customer Support. Today we're going to be covering configuring CDRouter for TR-069. First thing we're going to do is connect to CDRouter. CDRouter's web interface for configuration and running your tests. First thing you see is the front page here. We're going to go to configurations, and we'll start off by just creating a new config file by clicking the new config button. This opens up the configuration editor. The CDRouter configuration file is broken up into sections with the most common functionality up at the top and moving on to other areas. Initially, when you're setting up a new configuration file, you'll want to enter your configuration file name. You need to have your CDRouter system connected to the device that you're going to be testing. You need one interface connected to the LAN, and so we will identify that here by uncommenting the LAN interface test var. Each of these variables called test vars tell CDRouter information about your setup. So on my system, I have Ethernet 3 or E3 connected to the LAN side of my device. The device I'm testing uses 192.168.1.1 for the private network, so I don't need to uncomment this because that's the default value. Next, I will scroll down to the WAN setup and do the same. And I'm going to leave the addressing at the default values. So CDRouter will assign an address to the device under test. And it will use this address, the WAN ISP IP, as its own address. Next, I'll uncomment the WAN mode. The WAN mode tells CDRouter how the device is expecting to obtain its IP address. My device is using DHCP, so I'll change this value to DHCP. So I'll click Check Config here to make sure I haven't made any mistakes and save my config. Next, we'll go over to Packages. A test package defines which tests you're going to run and also how you want CDRouter to run your tests. First, we'll give it a package name. We'll associate a configuration file with the package. And then I'll scroll down and select some TR-069 tests. And then we scroll back up and click Create Package. Now that we've determined that, let's go back into our configuration file. We can get to it straight from here. So to enable TR-069, really all we need to do is uncomment the ACS IP test var. CDRouter will create its own emulated ACS within memory. In the basic ACS configuration, we can leave all of these test vars at their default values. And in the default configuration, the ACS will run over HTTP. You can change any of these test vars to assign or to have the ACS start on a different port if you'd like. You can change timeout values for how long the ACS will wait for the device to send an inform message or some other response to a request. The ACS default user and password are the username and password that the device under test should use when connecting. You're going to have to configure your device under test with a URL or a means to connect to the ACS. I'm going to go to the management interface, select the TR-069 client, and here I've configured how to reach the ACS. There is a default host name I can use. So if I tell my device that the ACS can be reached via the hostname acs.qacafe.com, when it receives a DNS request for this hostname, it will automatically resolve it and return the ACS IP address that you've assigned. Make sure that the username and the ACS default user and the ACS default password from your configuration file match the settings on the device. For the ACS to reach the device in order to make connection requests, you'll need to make sure that the authentication credentials for your device for connection requests match the ACS CPE default user and password. I also need to make sure that the IP address of the CPE device for a connection request matches the device's assigned IP address, which is the LAN ISP assigned IP. This is the default connection request URL that the ACS will start out with. But anytime the device connects to the ACS and sends an inform message, typically the inform message will include the connection request URL for that the device requires. And whenever that's received by the ACS will update its own cache of what the connection request URLs is. So if your device, for whatever reason, uses a different connection request URL or changes its connection request URL periodically, the ACS will always stay updated with whatever is current based on what it receives directly from the device. So after doing this, we'll just do check config again and save our configuration. Then we can go back over to our package and launch the test. We'll go over and reboot our device. Then we click unpause. And the test is running. You can see the progress up here. And over here, there's a indicator for which test is running and how long it's been running for. We can click on the log link to see the log file thus far. And this shows all the progress for this particular test. The first one is the start procedure, which basically initializes all the services. And you can see here that CDRouter started up TR-069, enabled the ACS at IP address 6.0.0.1, starting it on port 80 using digest authentication, and so on and so forth. After that, we see TR-069 get initialized. CDRouter assumes that all devices, when they boot up, they will initiate a connection to the ACS on their own. This can be overridden in the configuration file, but by default, the ACS or the CDRouter in the start procedure will just wait for that initial inform from the CB device. What I'm going to point out here is just that whenever the ACS receives the message from the device under test, it will display the message that's coming in and decode the XML and display it here so you can analyze the contents and see what's provided and contained in the message. As I pointed out, the connection request URL is received with the inform message, so that is the ACS is going to take that and update it. It uses the OUI and serial number as a unique identifier for this CPE device. And then CDRouter gathers some information from the data model of the device. CDRouter then initializes CWMP profiles. Profiles are basically sets of parameters from various broadband forum specifications that define all of the data model parameters that a device can support, and it identifies which of those that this device reports that it does support, and those are eligible to be tested in the various profile test modules that are supported by CDRouter, and I'll go into those in a minute. Basically, CDRouter will receive each of these so that it knows what parameters are supported, and then querying for each of the parameters defined within the profile and making sure that the value is returned. For newer devices that support the device 2 data model, the device summary parameter is no longer has been deprecated and may not be supported, but CDRouter allows you to essentially define a device summary in place of having received one from the device, and that can be part of your configuration so that you can indicate to CDRouter which profiles are supported by the device. So let's go back from the start, back to our test run, and look at our results. And you can see that all of the tests run. You can go into each of these test logs to see the progress of the test, and it will show each of the RPC exchanges. So that's an example of TR-069 running over basic HTTP. Let's go and change our configuration to support SSL now. So we'll go back to the configurations tab, open our config. Instead of leaving the defaults, we'll uncomment these test vars. And to enable SSL, at a minimum, the only ones we need to change are the transport and the transport port. So instead of HTTP, we'll say HTTPS, and we'll change this to a default port of 443. Now by default, when SSL is enabled for the ACS, CDRouter will use a default certificate that we provide when CDRouter is installed. This certificate is contained in the in the following location on your CDRouter system in user share doc CDRouter acs.qacafe.com.pem. So the certificate is in the plaintext PEM format. This is a official certificate that was obtained from VeriSign and is signed by VeriSign certificate authorities. So it should be recognized by most devices. The certificate file contains both the certificate and the private key that is used to encrypt traffic and encrypt messages sent over the SSL connection. And the private key obviously is not sent to the device, but this file contains both of those elements that is used by the ACS in order to establish an SSL connection with the device. So now we'll go over to our TR-069 client configuration and set this up for SSL. On this device, that's done just by changing transport. So we'll change that to HTTPS and save. We'll save our config, go back to the package and launch. In this instance now that we're running over SSL, you can see log information detailing the connection as it proceeds, and that the certificate is being sent and exchanged with the device. So that's essentially the basics of, that's all it takes to enable SSL for TR-069. I'll go back into the config and take a look at some of the other settings that you may be interested in looking at that may influence the testing, the configuration for your setup, depending on what your requirements are. The ACS certificate is specified by the ACS search path test var. There's also other certificates. We provide a signed certificate for a download server. So for any upload and download tests that are run over SSL, CDRouter will create a separate file server entity that has its own certificate, and that when the ACS directs the device to it for a download or to upload a file, that virtual file server will send its own certificate that is also signed, so that the device can validate it before performing the file transfer. In addition to the certificate itself, there's also a path where you can specify the certificate of the certificate authority that signed the ACS's certificate. That's quite a mouthful. But essentially, the reason for this is if you have, there's a couple of reasons. If the default certificate that the ACS uses cannot be validated for your device for any reason. For instance, if your device does not recognize the VeriSign CA, you can add the certificate of the VeriSign CA from this file to your device. So for instance, if we go over to this device, the acs.qacafe.com-ca.pem file is the CA certificates file, and the first one in that file is the root CA. You can then copy and paste into your device. So I'll just give you a quick example of that. And there you go. By entering this in manually onto the device, it tells the device that if it receives a certificate that is signed by this CA, by this certificate authority, then the device can trust it and can mark it as valid. Without this, well, in this particular case, the device already has this particular CA pre-configured. So I was just adding it manually as an extra step. But if you were to use private certificates that you create yourself that are not pre-configured, and I'll go into that as a next step and follow an example of that. If you want the ACS to use its own certificate that you've created yourself, you're going to need to tell your device that that certificate can be trusted, either directly or by a certificate authority. And in that case, you would have to add the information about the certificate authority onto your device. In addition to the default certificates, we also provide a self-signed certificate that is not signed by VeriSign. It's signed by ourselves. Because it's locally created, devices would not recognize it and they would not validate the certificate unless we provide the certificate of the authority that signed it, which is contained in the acs.qacafe.com.ca-self file. So if we look at this file, this contains a certificate for our private self-signed certificate. There's more information about adding certificates, adding private certificates in the TR-069 user guide, which you can find on the Support QA Cafe customer support site under user guides. In the configuration section, we cover all of the steps that I've covered during this webinar: enabling the ACS, configuring SSL, and using self-signed certificates. So here, and I'll do this in the configuration as well, but essentially all you need to do is uncomment the ACS cert path and ACS CA cert path and specify the certificates that you have created yourself, or you can use our own self-signed certificates if you like. And during the check configs, CDRouter makes a quick check to make sure that these are readable. If I specify a file that doesn't exist, that will flag an error so that you can catch it before you actually run your test, to save you some time. And we can save our config and run our tests. And I'm just going to jump over to results showing where we've done that. So if you want to verify that certificates are being read, that is contained in the log file. So it shows when the ACS is started up, it shows which certificate files are being used. And then, you know, if you want to go even further, you can look at the packet contents and see that the certificates are being exchanged at the start of the SSL connection negotiation. All right, so that covers basically the basics of setting up TR-069 for CDRouter and creating your first configuration files and running some basic tests. I've only selected a few tests here, but there are hundreds of tests in the TR-069 add-on. The documentation section shows all of the test cases that are available and descriptions of them. The TR-069 add-on is actually two separate add-ons that are available. The basic TR-069 add-on contains the OD128 test plan from the Broadband Forum, an implementation of that test plan, as well as a number of tests that we've created beyond that test plan that verify CWMP functionality on the device. And there are some there are a large number of profile tests, and these getting back to the device info parameter that the device may support to declare which parameter profiles are supported. For each of those profiles, CDRouter provides a set of tests that can verify the integrity of the profile. Essentially, there are 7 tests for every profile recognized that can be run. And these tests essentially get each parameter by name at various levels within the hierarchy of the data model. They'll verify that the parameters are defined correctly in the data model when they are returned from a get parameter names RPC. They'll verify that a value is returned for the parameter. They'll verify that the parameter can be set. This is a generic test where where CDRouter, where each of the tests essentially gets the current value and then attempts to send a set parameter values RPC for that same value. So in some cases that the parameter should just be able to be set to its current value. Some parameters don't support setting parameters in this way, and you'll have to exclude them because it's basically not, these tests are not sophisticated enough to do range testing or set parameters for specific values or different values than what's currently set. So it's a little bit of a limitation of this type of test, but it basically gives you a good confidence level of what the integrity of your data model is for the device. There's a test file available called TR-069 fake device summary that can be used to specify a different set of supported parameters in the case that your device doesn't fully support a particular profile, or if you want to exclude certain profiles, if your device claims it supports profiles that it doesn't fully support, it doesn't support at all, you can redefine what is supported in this test file here. Yeah, thank you for joining, and hope you all have a good day, and we'll be in touch soon. Thank you.